Hello all, here's a quick proof of concept demo on the fully automated startup of a Celestron telescope controlled by a Nexstar. Here we've got an SE base and we've got a 6-tube mounted on the base, and what I want to do is I want to press the various keys. And so we're going to press the enter key with the servo, we're going to press the align key with the servo, and we're going to press the scroll down key with the servo. Now these servos are all controlled by an ESP32 serving a web page, so it can all be automated remotely. And so what we've got here is the web page, and so you can press the various keys, or you can have it do a full sequence and take you fully all the way to a fake align. So we're gonna, and that fake align is all part of, will be all explained in the next part of the demo, where we use index sensors on the SE base. And so we're going to come back over here, and it wants us to press enter, so we're going to come over here and tell it to do it all. So the first thing it's going to do is press the servo for enter key, and so now we're going to go down here. We're going to pick 2-star align, 1-star align, solar system align, equal north. Now I'm on a wedge. So now I'm going to come up here and press the time, enter the time. I don't care what the time is. I don't care what the date is. That's part of the second part of the demo. And then we're going to come down here and select 1-star align. And then we're going to pick any star and fake align it and align success. So we're fully up and running, didn't even touch it, all controlled remotely. Thank you very much. And now the rest of this is dealing with the adding index sensors to the SE base. So what I've got here is some track following, transmit, receive LEDs, and they're going to pick up on that little piece of aluminum foil on the azimuth base. And over here we've got transmit, receive LEDs, pick up on a little piece of aluminum foil on the altitude base. Now they're all fed into this receiver board, and the receiver board is being interfaced into a Pi 4. Okay, these are current limiting resistors if you're wondering what they are. So what the second part of this will be is we're going to do the fake align like we just did. We're going to drive to the index sensors, and then we're going to do a sync since we know where the index sensors are in the space-time, and we know what the local sidereal time is, and we know the offset of the azimuth sensor. Then we can set the right ascension, and the declination will be well defined by the altitude sensor. That'll be the second part of the demo. Thank you very much, everybody. Okay, this is the second part of a demo that will show the automatic setup of a 6SE Celestron telescope. Okay, I've got sensors for index marks on the azimuth axis and the altitude axis. So right now I'm going to come over here and connect, okay, to the scope. Okay, and I'm going to do my connection. Now I've told the scope that I'm January 1st, okay, and I'm synchronized on MISAR. So right now the scope thinks it's January 1st and looking at MISAR. Now I've got a utility program over here that will read the GPIO sensors, and there's this interface board that takes it into the Pi chip, and what I'm going to do is run this utility program, and it's going to go look for the sensors. Sorry about all the wiggling waggling. And so you can see it's looking for the azimuth sensor. Found the azimuth sensor. I was going to go look for the alt sensor. Found the alt sensor. And it's going to come back over here and set the right ascension and declination and the time of the mount. So right now it's pointing in the sky. I come over here to sky chart and telescope, connect telescope, connect. Oh, come on, you stupid thing. Okay, and now if we close this up, we see this is where the scope thinks it is in space. Okay, now we're going to come over here and we're going to scroll up. Remember, it started out on January 1st. It's now February 29th or something like that. So now we're going to come over here and we're going to tell it to go to Rigel. Telescope slew to Rigel. And scope is slewing. Okay, and now we're going to come over here and we're going to connect up CCD seal and we're going to take a picture and let's see if Rigel's in there. Oh, it's so cloudy now, I can't see a darn thing. Oh, there he is, he's peeking out down here. There he is. So there's Rigel. Okay, so this was, remember, scope started out January 1st at midnight. And we drove to the sensors. And then